a webinar series brought to you by CIM Magazine and the CIM Health and Safety Society. I am your organizer, Michelle Beacom, Managing Editor of CIM Magazine. Today's presentation is the Advancing Safety Through Clean Energy Technology and is sponsored by Tech Resources Limited. Just a little housekeeping before we get started. To ensure you have optimal audio, if you joined by computer, please make sure you've selected the computer audio button. If you joined by phone, please make sure you've selected the phone button. And if you have any questions during the presentation, please type them into the question box in your GoToWebinar control panel. It's underneath the question mark. Note that Note that we will have some poll questions during the webinar, so please pay attention. Thank you everyone for joining us today. We are excited to be partnering with the Health and Safety Society to be able to bring this series to you. And I'm very happy to have Jennifer Pakula with us today to moderate the webinar. Jennifer is Principal Ground Control Engineer at Hudbay Minerals and has more than 30 years of experience with the mining industry. She is currently Treasurer of CIM's Health and Safety Society. Welcome, Jennifer.
Thank you, Michelle. And our Advancing Safety Through Clean Engine Technology webinar is going to focus on the advances in underground prime movers, specifically around the impacts of the recent advances in engine technology. So our current standard for underground diesel is Tier 4, and these engines have been available for over 10 years now. The Tier 4 represented a substantial jump in emission reductions over the previous Tier 3 standard. Tier 5 engines are not commercially available, but will be coming out in the next 5 to 10 years, and they are projected to have next to zero emissions. The underground mining industry now also has access to mobile, solely battery-powered vehicles, or BEVs. This equipment is typically charged by switching the batteries or plugging into a charging post, making it much more versatile than trolley or tethered systems and less expensive than hybrids. Without further ado, let me introduce today's panelists. So I'll start with Andre Berriot. He is the Product and Application Specialist for Electrification with Epiroc. And Andre is a graduate of the Electronics Engineering Technology program at College Boreal in Sudbury. He joined the automation and electrical team at Epiroc in 2005, where he completed his apprenticeship and became a licensed industrial electrician. In this role, he was heavily involved in the very first battery electrification projects at Epiroc, converting the first scoop trams and mine trucks from diesel to battery electric. He is now proud to be in the role of Product and Application Specialist, Electrification, spreading the word about the benefits of electrification. And our other panelist is Cornelius Powell. He is with Hudbay Minerals, Manitoba Business Unit, and the Superintendent of Projects and Technology. Cornelius Powell is a seasoned professional with over 30 years of experience in the mining and oil and gas industries. He is responsible for overseeing the execution of the Lalor Mine capital project portfolio and advancing operational technology. Throughout his career, he has held diverse roles in maintenance, construction execution, and project management. He is recognized as a professional engineering technologist and holds a P-Tech engineering diploma from Vaal University of Technology in South Africa, along with various industry accreditations. He serves on several industry committees, and this includes his participation on the CSA Steering Committee, which is currently developing the standard for self-propelled, electrically driven mobile machines for use in underground mines. Cornell, I'm going to start with you. And our first question is, what are the top 3 safety benefits of battery electric vehicles?
Thank you, Jen. So the first major benefit is the reduced environmental exposure to our operators. Yes, battery electric vehicles, contribute significantly to production, and there's lots of advantages over that. But our operators are key, right? So we've seen, and also through ongoing collaboration with our operators, we've seen significant positive feedback as far as environmental exposure goes. So let me explain. So first of all, heat, which is a major contributor in mines, especially deep level mining, and ventilation requirements and restrictions. So there's a significant reduction of heat compared to internal combustion engine when we operate on in the deeper levels of the mine. We have completed a study in partnership with NRCan, and we've seen up to 2 degrees Celsius reduction in heat, between diesel equipment versus battery electric equipment. Then secondly, reduce noise. So exposure to noise in the workplace when we muck development rounds or stopes. Typical operators, they wear double ear protection when they muck these areas with diesel equipment, and with the battery BEVs, they actually just use regular earplugs. That's one of the biggest things that one of the most positive feedbacks I received from seasoned operators. One specific operator, being an equipment operator for more than 25 years, actually pulled me aside after we've rolled this program out in the mine, and he said that it's the first time in 25 years he could remove his double earplugs, which is significant for me, right? Then also vibrations. We've noticed and seen a lot less vibrations on the BEV equipment versus diesel equipment as well. So that's the first safety benefit, right? Secondly, obviously, the reduced risk of equipment fires. So lower operating temperatures, no high heat combustion engine components, right? That run the risk of igniting fuel or oil when we have hydraulic hose failure or something like that. So here at Lalor Mine, I did a poll from 2014 until recently, and of all the fires we had underground, none of them were battery electric related. They were all diesel combustion engine related. So definitely a reduced risk of equipment fires. And then one of the biggest ones as well is no diesel particulates in the areas where we operate BEV equipment. So Jen, you alluded to tier 4. Well, we started off with tier 3, tier 4, and tier 5 in future, right? Which is highly focused on reduced emissions from the internal combustion engine, but the biggest silent killer, because it's not visible to the naked eye, is the actual diesel particulates. So knowing that we're eliminating diesel particulates when we operate BEV equipment is also a very important step for us. Thank you.
Thank you, Cornell. I think now that we know some of the benefits, maybe we'll go to a poll. And if Michelle, you got that poll question up there, and while everyone's typing in their answer, I'll remind you to also type in your questions, because we will get to those at the end. Now, before we get to those results, Cornell, maybe you could tell us a little bit about Hudbay's journey into the use of BEVs.
Sure, Jen. So we started this journey back in 2023 when we secured an R&D project or initiative with our OEM, and our first piece of equipment was a ST14 BEV LHD. So LHDs are used to move primary muck from the heading or the face. We load that into trucks and we transport the muck from that location with trucks up to wherever we process the ore. So that's the LHDs are the workhorses in our fleet, And we were lucky enough to secure one of the first LHDs that was rolled out to the mines. And we started off this project with complete collaboration in mind, total transparency and complete collaboration, not only with our partners in the federal government through NRCan, but also with our employees, the people that will actually operate and also work in the mine where we plan to use this equipment. So the first LHD arrived on site, as I said, in 2023. We put it through its paces. We ran a comprehensive study through NRCan to compare diesel to BEV to see if the promise is there, what the OEM provided us, right? And from the first day, it performed above expectations. Noticeably, if you can recall, the three most important safety advantages of BEV equipment is, reduced noise, maximum torque from 0 RPM, which is a big advantage for us. With diesel equipment, you need to operate around 1,000 RPMs to have, significant or enough torque to load and dump the muck. But with BEV equipment, completely silent, you've got torque right from the moment you press on the pedal. So we ran a comparison between diesel, the time it takes to muck around, how many buckets they get through a cycle, versus battery, and the battery scoop actually matched the diesel, for every cycle of the round. So that's where we started. We looked at charging infrastructure because we wanted to use this equipment everywhere in the mine. So, with the engineering team, we designed, our charging infrastructure in such a way that we can have access to opportunity charging on the LHDs, and we can, charge whenever the operator takes a break or he goes for lunch or, anything like that. And to ensure he's close to a charging location or outlet at any point in time. So we progressed through 2023 into 2024, 2025 to where we are to today, where we have more than half of our LHD fleet is BEVs right now. Our trucks will be 50-50 split by the end of this year between battery and diesel. And we also procured a jumbo drill that is battery electric. So we are looking at currently we're looking at maybe continue with a 50-50 hybrid approach in the existing part of the mine where we didn't had this technology available to us when the mine was designed and laid out. But we definitely, through our engineering team, are designing new lenses, ore bodies, and other parts of the mine with battery electric in mind. So, continuing on through our life of mine, and also with the rapid development of fast charging technology and the new generation batteries that we get from our OEM. Before the end of life of mine, we most probably will be close to 100% electric fleet.
That's really interesting. Thank you, Cornell. We'll jump back to what everyone saw as the risks. And it looks like there's some concern over cost, about the same amount of concern over fire, but the biggest amount around how do you manage the charging. So we may come back to that eventually, but it is interesting to note that nobody thought that worker acceptance would be an issue. So maybe I'll jump to you now, Andy, and note that with any change in technology, there can be barriers to adopting it. So what are some of the barriers that Epiroc has encountered while developing the BEVs?
I'd say, first and foremost, I think the biggest barrier, especially for our very first adopters, the early adopters, was safety. Safety number one. especially going to an underground mine. The safety of the product has to be paramount. Everybody has a health and safety program. Batteries really put the health back into the health and safety program. But the actual safety of the product itself was the number one barrier to overcome. We had to demonstrate to all of our mining customers, all of our potential customers, that batteries can be as safe as diesel, that we've done our due diligence. We've incorporated all of these safety features into the design of the battery. And our first adopters, I think, are quite pleased with the way the batteries have been. They're demonstrably safe. Now we've got 7 years of track record to show that we have no major incidents with our batteries. As Cornell demonstrated that any thermal incidents they've had with the existence of the battery fleet, there's been no incidents with the batteries at all. You actually reduce your chances of having fires. So after we can convince our customers that they can be just as safe, we've done our due diligence, you are in good hands. After that, the barriers are pretty much the same as they are in the public sector. So when you look at the main barriers for adopting BEV in the public, it's people want the batteries to last longer. So range anxiety is real. In the mining industry, that translates to our customers want to see full shift operation. And we're not quite there yet. We can get easily, I'd say, half a shift. But then you either have to swap the battery or charge the battery. In trucking, that could be trucking could be very challenging. You could be changing batteries 2 or 3 times a shift, depending how intense your application is. So longer lasting batteries is the first barrier. People want the batteries to charge faster. So charging over shift change is great, but if you want to charge during shift, charging in 2 or 3 hours, that's just not very convenient. So charging faster, making a charge stop the same as a fuel stop, that was the other barrier. And then, as always, cost. People want their BEV to be parity or on par with the diesel cost. And right now, it's a very tricky thing to evaluate. If you just take the TCO if you're going to run a battery machine right beside a diesel machine, change nothing, just use one day, the other day, not adjust your ventilation, not change your cooling, not do anything, the battery machine will cost more to run than the diesel machine. There's no doubt. You have to do a lot of things to capitalize on all the financial gains that you can have with BEV. What we're seeing a lot of our customers are doing, though, is you have to look at the cost per ton rather than the cost per hour. A lot of our customers are using BEVs to get tons that they couldn't get with diesel machines. So if you've got, there are old headings now that maybe the ventilation is not what it was when they first developed the mine, but commodity prices are driving customers back to those headings to get the ore out of there that they might have left behind years ago, or in the deeper part of the mine where it's really, really hot and ventilation is hard to get there. Our customers are limited to how many diesel machines they can run, but they can get more tons with the battery machine, and they're bonus tons. They're tons they couldn't get with a diesel machine. So now if you look at the cost of a ton that you get with a battery machine, yeah, it's more than you would have paid for a diesel machine, but it's a ton you couldn't have got. So it's a bonus ton. If you want to run the machines at parity, there's a few things that need to happen there. So one of the things, when we first launched our battery machines, the price of batteries we anticipated would go down, and it went up on a steep trend for several years before we thought they would plateau. Now they're finally starting to dip lower, and they're coming back. But one of the things that we will be introducing in the next, in near term and mid to long term, will be faster charging batteries. So very shortly, Epiroc will be introducing a hardware update. Will allow batteries to charge double, maybe even triple the speed they're charging at now. And then also more capacity, that's coming as well. And in the next few years, the charging speed will go 4 to 5 times faster. So that inherently will change the cost of batteries, because you will need less batteries to do the same job. So a loader that used to use 2 batteries will now more than likely only use 1. Trucks that were using 2 or 3 batteries will be down to 2, probably even 1 in the next few years. So even if the cost of batteries is somewhat unpredictable, a lot of that has to do with political climate. Even if it was to just level out where it is now, the cost of batteries is slightly coming down, but the amount of batteries you need will definitely go down. So that will reduce the cost of batteries to the customer. The other thing is to actually take advantage of everything you can do to reduce the cost of your battery machines. So using your ventilation on demand, using your government grants, your carbon credits, your tax rebates, all of those things. If you can take advantage of those, your TCO will be at par or even less than a diesel machine.
No, that's great, and definitely points to the longer term engineering to design your mine to take advantage of it. And of course, the government grants, if any are out there, that's also a great selling point. Cornell, were any grants available for when you implemented BEVs at your mine?
Yeah, for sure. So to Andy's point, so what we, if we design a piece of equipment for procurement, we have a specific HUD-based specification that we would like to see when the equipment arrive on site. So that's obviously added dollars to the baseline of the model, but we've been purchasing diesel and BEV LHDs in the same financial year, and with the government or the federal rebates, BEVs is within a few $1,000s at the end of the day compared to diesel equipment. So you get the BEV technology, which is highly explored right now, and there's a real push on advancing that technology versus diesel. So you're always on the cutting edge of that technology, and also the federal grants and credits are real. We get them every time. We have like a part of our financial department in conjunction with our environmental group. They apply for these grants for us, and we receive them in a timely fashion. We are also currently exploring federal carbon credit opportunities as well, as far as charging goes, right? So, we charge batteries. Up here in northern Manitoba, we use hydropower, so green electricity. So, not having to use fossil fuels and rather relying on green electricity, there's some credits there as well. So yeah, it's real. We do get them, and we get them in a timely manner as well.
Oh, that's good news, and I'm sure everyone will take advantage of that when they take steps in this direction. I think the next thing we'll do is pull up our next poll. And remember, as you're answering it, to also put your questions in the question box so we can get to those after. But this poll is around, like, if you had to design your fleet, how much of it would be BEV and how much of it would be that brand new Tier 5 engine when it comes out. So diesel or electric, which is the best way to go? And we'd love to hear your opinions on that. And while we do, maybe I'll jump back to you, Andy. And I don't know if Epiroc was able to get any funding around developing BEVs, but what was your journey like in going along the BEV path?
Yeah, for us, I mean, the initial development of our Gen 2 equipment is most popular out there right now, that started off as a SIMS initiative in Sweden. So there was some government funding involved there in kicking off that technology. So yeah, there's definitely some incentives there for companies to advance green technology. Green grants are the same for users as well as developers. So that's definitely a plus there. We've seen the advancement of the battery change such that, in the coming years, we'll be able to, just the hardware implementations. For example, when we first launched our battery, we used the CCS connector. It's an agnostic connector. It's the same connector that's used in the automotive industry. So it's agnostic. Any OEM or any mining supplier that chooses to use that standard, if they want to use any charger that follows that standard, they can charge an Epiroc battery, or an Epiroc charger can charge any battery that uses that standard. It's agnostic, and it's a global standard. The hardware that was existing when we first started launching our batteries in 2018, 19, the max amperage for that connector was 200 amp. But now in the last few years, they've introduced a charger connector that is up to 500 amp. So for us, that means with a hardware update, we can double or even triple the charging speed of our batteries. And in the coming years, there'll be battery technology. The cells will be able to handle faster charging. The hardware will go to mega charge connectors, and we'll be able to charge, 5 to 6 times faster than we currently are, which means hours of runtime for minutes of charging. It'll really change the whole dynamic of the charging and using. There's no reason now with the charger technology, if you've got a charger with charge dispensers that can be hundreds of meters away, and don't forget that hundreds of meters can be vertical. So you can have a charging network in the mine that is, it can make charging just as easy and just as fast as a fuel stop. So the philosophy of we'll build a charge bay or a swap bay, and that's where the BEVs will go to charge and swap, that will change to the charge bay is wherever you put a charger. There'll be a dispenser, there'll be a charging network, it'll be a decentralized charging system where, you can manage power and say, oh, there's a truck that's charging now that doesn't need to be used until next shift. So we'll divert power to the scoop that's charging for the next few minutes that needs to run another 3 or 4 hours. So for us, the journey has been really, let's implement the safe technology, allow people to get their feet wet. And now that the dependability is going up, the availability of the machine is up, it's on par or even better than the diesel machines. And now it's actually getting the utilization through charging strategies. A lot of customers were just the pure charging, you have to plug it in at the end of the shift. You have to make sure there's one battery per charger. If you plug in 2 batteries on one charger and the other charger doesn't have any batteries, it cuts the speed in half. Just little things like that were barriers to getting the full potential utilization of the machine. So now I think with smarter products and mines that are really on board with larger fleets and actually strategizing and getting the full utilization of the machines, that's making the utilization go up to be on par with the diesel machines.
Excellent. That sounds like it's almost a wash in which one to go with now for time at the face. So, and looking at our poll, more of a split opinion this time. Some people are willing to hold out for that Tier 5 engine to become commercially available, and we'll go with that. About 15% at 75% diesel, 25% battery electric, 42% 50-50, and then 18% at 75% battery electric, and 15% at 100% battery electric. So I think a lot of this may have to do with corporate strategy as well on how companies want to present. But for now, the question I'm going to ask is, are 100% BEVs ultimately sustainable, or is a hybrid solution a better fit? So Cornell, is there a reason why Hudbay decided to go with multiple BEVs rather than just, trying out one? And is 100% BEV fleet in the future for Hudbay?
Thank you, Jane. Yes. So with the existing mine design, Hudbay planned to operate a hybrid fleet consisting of internal combustion engines and BEV equipment for the near future. However, as new ore bodies are being developed, we will design it in such a way that we could transition from a hybrid fleet approach to a complete BEV fleet. Further, battery technology and charging capacities are being developed at a rapid rate, exceeding diesel technology advancement. And the early results show that we will be able to replace diesel equipment currently utilized for heavy lifting in the lower parts of the mine with BEV equivalent equipment before 2030. So as we open up new ore bodies or lenses, we can design to accommodate BEVs, whereas in the existing mine, which was designed with the diesel fleet in mind, it's a little bit harder to transition to full battery electric. So yes, for the short term, we definitely plan on utilizing our diesel fleet, But as this the diesel equipment reach maturity and needs to be cycled out at end of life, we will definitely replace them with BEV equipment.
Yeah,
Okay.
I concur with Cornell there. I think going BEV underground is, I think it's inevitable, whether you think it's in 2 years, 5 years, 10 years, 20 years. I think it's eventually inevitable. Trucking is still if you're going to haul 4, 5, 6, 10 kilometers uphill with a loaded truck, doing on battery is going to be a challenge for a few years yet. But when we can demonstrate that a truck can run hours on a charge and charge faster than a fuel stop, that will really, the naysayers it'll be undeniable that it's as effective. I think electricity and the efficiency of electricity as a power source is always going to be less expensive than diesel, more manageable. So like Cornell said, I think you're going to see a lot of customers slowly start to phase in battery, and eventually the diesel will phase out.
Yes,
Yeah,
Andre, thank you for that. Also to note, sorry, Jen, also to note, we have insurance auditors that come and audit us on an annual basis. And the feedback we receive from the auditors is that they are much more in favor of a BEV fleet versus a diesel fleet. Diesel fleet carries so much more inherent risks. Storing large capacity diesel underground, right, is a risk on its own. Internal combustion engines, the temperatures, and just the amount of fires we've had underground on internal combustion engines. So just from an insurance, point of view, they prefer us using BEV rather than diesel equipment underground. And I always tell the workforce, they're in my office all the time, we collaborate about these things. I always tell them to get diesel underground require manpower, and electricity don't. So that's the two key things, right? We need to utilize manpower, exposing us to other kinds of risk, transporting diesel, right, in cubes and multiple places into the mine where power gets sent underground automatically.
Yeah, that's a good point too. And I did have one follow-up for you, Andy, and I know you probably don't have the exact numbers in front of you, but has Epiroc seen an uptake in BEV versus diesel sales at all? Or what are
Yeah,
your projections that way?
absolutely. It's been a pleasant surprise, especially in the Canadian market. The adoption, the incentives and grants have to do with that. The fact that most places in Canada use clean energy, hydropower. It's been a significantly higher, faster adoption. So we've had, a larger percentage of our battery sales. The piece of the pie for battery machines compared to diesel is larger in Canada than it is globally. I think it's going to go nowhere but up from there. I think the amount of customers now that are using it successfully they're just positive cases for other customers that were kind of doing the wait and see thing. We do expect it to be a 50-50 by the time. Part of our mandate is to have a BEV option for every single machine in the portfolio. The challenge right now is we only have certain models that are available in BEV. So if that's not the model that you require, then you're kind of stuck. But with the advancement now, with the whole portfolio having an option, it'll be much closer to parity a lot faster than anticipated, I think.
Yes, that's good news for the BEV industry for sure. Now, I know we're getting a little short on time, and I want to leave some time for the questions, but I do have one more prepared question. And I know that our webinar would not be complete without asking about how the people that are actually using the BEVs have reacted to them. And maybe I'll go to you first, Cornell. Are there some positives and negatives, issues, benefits that operators have brought up with you? I know you mentioned the fellow who doesn't need his double hearing protection anymore, and that's pretty sweet.
So interesting enough, thank you for the question, Jen. Interesting enough, Um, we're looking at operators, the younger generation operators. They adapt to technology like a lot quicker than, typically quicker than older generation operators. However, in this case, it's the older generation operators that have adapted uh, quicker than the younger ones, to a point where um, some days it's quite a battle. They fight over who's going to operate the BV LHD, and obviously the more senior operators always win, right? But yeah, so on a positive side, the operators love operating this equipment just because of the environment it creates, right? You're in a AC, air-conditioned cab, which is insulated, right? You just wear standard earplugs when you work in a heading. The heading is less violent, if I can call it that, where you've got dust kicking up, with big diesel cooling fans, because you run at 1,000 RPMs, right? So that kicks up a lot of dust. That doesn't happen. You don't have to rev the RPMs up to 1,000 to get any torque out of it. You've got maximum torque at 0 RPMs. And then also, just the equipment is a lot more smoother, right? So your hydraulic pump gets driven by DC battery versus an internal combustion engine. So the actual operation of the equipment is a lot smoother, which also helps us when we do remote mucking, right? Whether it's remote mucking on the level when we muck a stope or a development heading, or remote mucking from a control room up on surface. So we have actually moved, or are in the process of moving away from having to have operators in the cab all the time, right? The operator now dresses in office attire with street shoes. He sits behind a control desk and he mucks these headings from surface. So that's all the advantages of the new technology. Some of the challenges is like some of the listeners pointed out, was how do we set up the mine, the existing mine, as far as having access to charging locations, right? So as we progress further down the mine and further away from our permanent infrastructure, whether we have to fill a diesel scoop with fuel, right? It's sometimes it's up to an hour round trip to get to the main fuel bay, right? So we had to get fuel trucks to drive around the mine and fill the equipment at location. But we have the opportunity to install chargers close to our high yield stopes. We look at our 3-month forecast production plan, and we identify which areas are we going to mine at a high rate in the upcoming 3 months, and we drop a charger right there, so that the BEV equipment does not have to drive that far to get charged, right? So that was some of the challenges. The other challenge is actually more on a management side, is getting the right procedures in place, making sure we do a comprehensive risk assessment, having our workforce included into that, our health and safety stewards, our co-chairs, and all of that, right? And it's look at it from an overall holistic point of view. It's like getting all that documentation developed, getting it reviewed, and making sure it's fit for purpose. Documentation around how do we transport batteries from surface to underground. What's the procedure around a damaged battery if we haven't had one yet, but if we would have one, right? And all these procedures are also, it's worth to mention, it's been developed with support from our CSA subcommittees. So developing the underground standard for battery electric equipment, we collaborate globally on these things, right? And we look at what other countries and other companies are doing, and if it works for us, we adopt some of them. And we've developed quite a bit of procedures ourselves, which other companies have adopted, right? So definitely that collaboration is helping in that effect, but it's making sure we've got all the systems in place, all the risks identified, mitigations in place, and also mitigations around firefighting procedures. What do we do in case of a fire, right? And making sure we train our workforce, and ensuring that they understand that everything any concern or issues raised are being dealt with from a risk management point of view.
Thanks, Cornell. And maybe Andy, I'll go to you as well. I know as an OEM, you are sure to hear back if there is something that the client isn't satisfied with. So have you managed to address any challenges that were presented to you, or are they in your roadmap looking ahead?
Yeah, for sure. I mean, as Cornell alluded, involving everybody from a management level, I mean, senior management to procurement down to the operations is really key. These machines get to site and they're under a microscope. Make no doubt about it. Everybody's watching. Is it going to do as well? If you're, when we looked at some of the reasons for adopting, sometimes a mine will get a machine and it's just to get a green check mark on their corporate scorecard. It has nothing to do with ventilation. It has nothing to do with it's hot down there, we can't run diesel. They told their shareholders, they told the public that they were a green company. We're going to put a battery machine in a fleet, and that we check that box. If that machine gets to site and the operations have, what is this? I didn't buy into this. I need to get my tons, and I don't need to do all these change management for these machines. If there's not buy-in from everyone, then it's not going to work. The machine is going to be under a microscope no matter what. And if the person running the microscope is just waiting to say, I told you this wouldn't work, then it's not going to work. But when you have a good partnership with everyone at the mine and you can involve everyone, Hud Bay is the perfect example of it can work. If everybody wants it to work, it'll work. So that was a major thing. At the same time, that's how we learn. When it's under a microscope, every time something happens, we hear about it, we're on it, we address those problems, fix them in future designs and technology updates, that kind of thing. But when you hear, when the battery jumbo is down, it can be down for a hose, but it's still the battery jumbo is down. That's the way it goes. We've learned a lot. Changing all these procedures, all the work we've done with Hud Bay to help develop those procedures, that just makes us better at it now, and it helps us do it with the next customer. So that's getting better and better and easier just from the experience we've had with great partnerships we've had with companies like Hud Bay and yourselves.
Okay, thank you, Andy. And now we're going to take some time to answer some questions from the audience. And there's still some time to type some more in there if you'd like to. Just click on the question mark. And the first one is really specific, Cornell, and it's around a comment you made earlier over there being no fires caused by BEV. And the question was, what was the ratio of BEV equipment to diesel during the time period that you measured that?
Yeah, that's an interesting question, and thank you for that. So, I have the numbers, I can dig it up, but if I just have to generalize, it's most probably a 25 to 30% to 70% split, 30% being BEV hours and 70% being diesel hours. So yeah, definitely ratio-wise, it's not 50-50, right? But we started looking at this, when we introduced BEV at the mine, right? But we also used the OEM's data from 2014 when the first BEV piece of equipment was released, right? So we ran it from 2014 until 2024, and we looked at Hud Bay specifically, and also relying on the information we received from the OEM prior to 2023 when we received the first BEV equipment on site here. So Andy, correct me if I'm wrong, but I think it's close to a 30-70% ratio as far as equipment hours go.
In Canada, yeah. But just to further what Cornell is saying, even if you look at the per 100 BEVs sold or in the mining industry as well as the automotive industry, just at per capita, the number of fires per battery machine or per diesel or ICE machine it's a fraction. It's much, much less. When there is an incident, they get a lot of attention, but when you look at the numbers, there's much, much less.
Okay, that's really interesting, and it kind of leads into my next question, and it has to do with how much time it takes to do each thing. So I know at our mine we have two main spots you can fuel up. There's also a fuel truck we could send around, but how much time, comparison-wise, does it take to top up your tank on your battery as opposed to drive all the way to the fuel bay and literally top up your tank?
I'll go first. So we actually have real-time data because we are tracking that, right? That's part of this whole process, is to make sure that we, have a matrix that we can compare apples to apples, right? So to Jen's point, we've got two main fuel bays in the mine, where we mine down at the 1,300-meter level right now. The fuel bay is located up at 910-meter level. So for a round trip for a piece of equipment to go and get filled at the fuel bay is up to an hour. With the truck, it's probably just under an hour. LHD was probably a little bit more than an hour. Yes, we have a fuel truck, running around the mine, topping up equipment as required, but we have multiple equipment that needs topping up right through the day. So we always end up with equipment waiting for fuel. Doesn't matter where they are located in the mine. As I mentioned earlier, through smart design and layout of our charging infrastructure in the mine, we are utilizing opportunity charging with our LHD fleet, and we set these charging locations up really close to high yield stopes or stopes that we plan on mucking extensively over the next 3 months. So with our latest ST18 B6 battery technology, with the B6 battery technology that we received with a 400 paired with a 480 kilowatt charger, we are actually seeing charging rates, exceptional charging rates. The battery from 20% up to 90% charge rate is like less than 70 minutes. So just over an hour for a full charge on that. So, and if you look at utilization on the ST18, we can muck around, right? What we typically see, we muck a full round on a battery on a charge. We put it on charge. The operator breaks for lunch or coffee. It doesn't matter where he is in his day, right? We keep it on charge for an hour. It's fully charged by the time the operator returns, and then he drives and go and muck the next round, right? And so the cycle continue. We also ensure we've got an agnostic monitoring platform at the mine, so we can track all equipment at any point in time. We also track all batteries, right? Not only battery location, but also battery performance, some critical information parameters that we want to see on the battery at all times. So at the end of shift, we park the equipment at these charging locations. Through our control room, they monitor the charge. They know the status of the battery, the charge level of the battery. And when the next shift goes underground, they get dispatched to specific equipment, knowing exactly what the charge rate is, and they use that equipment then as planned for that shift, right, or the cycle. Whereas diesel, you never know what you show up to, right? You have to do all the pre-ops that the guys do, quite extensively, but there is a lot of times when they show up and the equipment is half full of fuel or a quarter full of fuel, and then they wait, either have to drive to go and get it filled up, or they wait to be filled up. And we've consistently seen BEV equipments being out in the field or in the phase in production before diesel equipment.
Okay, excellent. I guess I know how things are handled when I run out of my diesel fuel and have to wait to be rescued. Andy, how do you handle that with an electric machine?
Yeah, so range anxiety is, I said it's real. It's so real that we have actually never had a customer say an operator used the machine until it died and couldn't drive to the swap bay. We have a much more common occurrence is the utilization is down, but we look into it and the operators are going back to the charge bay when there's still 30% left. That's much more common than running out of battery. don't get me wrong, we've had, a breakdown and have to tow back, that kind of thing happens. But to say that a machine had to get towed back because the operator ran it dry, that's a super rare occurrence. I've never actually heard of it with all of our machines out there. It's more common the other way around. The range anxiety is so real that the operators are fueling or going to the charge station much, much earlier than they actually need to. Our current battery technology, on the scoops, it's roughly a 2-to-1 ratio for on the 8 yard at least. It's you charge for half an hour, you get an extra hour's runtime. But that will be changing very soon to a 4 or 5-to-1, and in the next year or two, it could be a 6, 7, or 8-to-1. So, and like I said, the distribution of the chargers now is so much easier than a fuel bay. Like I said, if you can have one charger with charge dispensers that can be hundreds of meters up and down and out, you can have a charge network that the charger can be a few hundred meters away from when the machine is working at any time, and you can get 3, 4, 5 hours of runtime on a 15-minute stop. So literally, if you're waiting for a truck to come by, you can charge, and you'll never have to actually park that machine for extended periods of time to actually charge it.
Okay, that's good to know, and it sounds like the perfect time to jump on the BEV wagon, because you'll be coming into the industry right when it becomes even faster than fueling up your diesel engine.
Yeah,
The other thing I was left wondering, Andy, was about maintenance PM times. I know we have like 300, 500-hour services. Do you have the same kind of maintenance schedule for the BEV engines?
there is the same intervals, because some of those things, but the intervals are the stops, the time they take are much, much shorter. Like for us, the first interval, everything is marked off it except for the cabin filter. So what used to be a bring it into the shop for half a shift, that maintenance interval might only be a walk around. We have definitely seen a reduction in maintenance costs on the BEV fleet compared to a diesel fleet. That's real, that's verified. Real life data can prove that out. The stops are they're as frequent but shorter. The batteries have their own stops and the machines have their own, but generally speaking, it's a much shorter time to service, to do a PM on a BEV than it is a diesel machine.
Okay, now I know we're getting close to the end, but I did want to jump back to get some more input on the risk around managing the charging of the batteries. That seems to be the majority question from the audience on, this is my concern. How do I manage getting everything charged?
So having smart chargers where you can monitor from surface, see who's actually charging, what's doing what, that you can dispense energy appropriately, that's one way to really manage that. I think we're probably reading into this question here is that we want to be able to charge batteries in 15, 20 minutes. That's a huge draw on the infrastructure. A lot of mines don't have that power, period, and don't have that power distributed throughout the mine, where those are megawatt level charging. Battery energy storage will be a big part of that in the future, where you'll have a local battery near the charger, that's on the ground near the charger, that you can trickle charge that battery all the time. It's always got 75 to 100% charge, and then when a machine pulls up, you can draw from that battery as well as drawing from the grid and double up onto your vehicle battery. So now you can have, and that's scalable. So now you can have a large battery energy storage so that you can charge batteries on vehicles when they get there very quickly without ever actually having a huge power draw on your infrastructure.
Yeah, to elaborate on Andy's point, so that's where we plan to go in the near future at Hudbay. So acknowledging that technology is improving, and we can charge at a much higher rate, but also be environmentally responsible. So what do we do with the batteries when it reaches end of life? While operating in the equipment, right? Rather than discarding that battery, and adding to our environmental footprint, we intend to actually use those batteries, like Andy said, as energy storage to fill in those peaks and valleys on our power demand, right? So looking at between shifts, that's when we dewater the mine, we waste, production wise, we still run ventilation underground, so we use a lot of power between shifts, but we also charge, right? So the plan is then to have those batteries that are not suitable anymore to be used in equipment as battery storage solutions throughout the mine.
Oh, that's
extending
excellent.
extending the life of the battery itself, right?
Yeah, and basically you're recycling your battery by still using it.
Yeah.
Yeah, so I guess to swing back to safety, what I'm hearing is that whether it's a battery electric vehicle or a Tier 5 engine, when they come out, the zero emissions is probably the biggest benefit so that we get rid of the diesel particulate. Then with the batteries themselves, there's less risk of fire, and then less vibration, less noise, less heat. So you can bring your ventilation costs down if you design for less air.
Yep.
Any final comments? I'll go to Andy first on the safety aspects.
Yeah, I mean the health benefit is massive. When Tier 5 engines come out, if they truly are 0 DPMs and 0 emissions, that's fantastic. But the noise, the heat, all of that stuff from a BEV it's there now, and that's only going to get better. It's actually, as Cornell pointed out, operators are actually clamoring to see who's going to get the EV, and it's a point of attraction and retaining talent. We see clients people are coming to them because they know there's a BEV fleet, or they don't want to leave because they like running BEV machines, and the mine next door doesn't have them, and they'll be going back to those stinky diesel machines that they don't really are a big fan of anymore now that they've been babied and spoiled with a BEV machine. So I think the health benefits and the safety benefits of BEV are here to stay, and if we can get the utilization up, we can get the adoption hiccups figured out, I think they're going to be here to stay.
Excellent. And Cornell?
Yeah, for sure, Jen. So just a little bit of insight, what we do here at Hut Bay and at specifically Lalor Mine. So we've got a mining fundamental school where we recruit local talent and we introduce them to mining. And, hopefully it's something they would like to pursue as a career, right? And we've seen with the students, one of the biggest drivers of why they sign up with Hut Bay is because of the fact that we have these fancy or new technology battery electric vehicles on site. Everybody wants to operate that equipment, and that's one of the key reasons why they sign on, to the mining fundamental program, but also ultimately want to join Hut Bay as well.
Okay. Unfortunately, we're out of time. So Cornell, Andy, thank you very much. Thanks to Tech.
You're welcome.
And I'm going to turn it back to Michelle.
Thanks, Jen. And thanks to our panelists, Andy and Cornell. Also, a special thanks to Tech Resources Limited for sponsoring today's episode of the Safety Share. I'd like to thank all of our attendees and ask that you please fill out the short survey that pops up on your screen at the close of the webinar. A link to the video recording of this webinar will be emailed to you tomorrow. We hope you will join us for our next episode of the Safety Share. Keep an eye on the calendar of events at cim.org for more details. Enjoy the rest of your day. Thank you. Bye.